Hi and hello everyone. In this video, I will show you how to use Newton's divided difference interpolating polynomial for you to approximate a value of a functions. Right. Before we go further, I would like to show you the general formula for this Newton's divided difference interpolating polynomial. Right. The formula is you'll have fn x equal to fx naught plus, alright, so this is x minus x naught, and this is the first divided differences which involve x1 and x naught, alright. Then you will extend this into x minus x naught. Then you multiply again with x minus x1 and multiply with the second divided differences, which is a combination of x2, x1 and x naught. Then you will carry on with x minus x naught, x minus x1, and multiply with x minus x2. Then you have to multiply by the third divided differences, which is a combination of x3, x2, x1 and x naught. And you can extend this formula up until the nth divided differences. So in general, it is x minus x naught, x minus x1, then you can multiply up into x minus x n minus 1. Then of course, you need to find out what is the nth divided differences, which is x n minus 1 and extend into x naught. So this is the general formula for Newton divided differences of nth order. So here what you have to take note is this is the first divided differences. So I'm going to show you here as this is first divided differences. I'm so sorry, my handwritten is so bad, but I hope that you can understand what I write here. So this is the second divided differences, and this is, of course, this is the third divided differences, and finally this is the nth order of divided differences, nth divided differences. Okay, so now what you have to do is you need to decide what order that you want to use. Say for example, you want to go for right, before we go to first order or second order, third order differences, I think I need to show you how to get these first divided differences. Okay, so the first divided differences, or we can put it here as, in order for us to find the first divided differences, this is the formula for it. This is, let's say we have a combination of xi and xj. So you need to get the value of the function for point xi minus the value for point xj, divide with the difference between the point xi minus xj. So this is the first divided differences. If you want to find the second divided differences, which is xi, xj and xk, So here, you need to find out the difference between the first divided differences. So this is a combination of xi, xj minus f. And this time around is supposed to be xj, xk. So look at the pattern here that you will combine these two, and then next you'll combine these two. Okay. Then you need to divide with the difference between this point and this point. So this is xi minus xk. Therefore, if let's say that you have n divided differences, so that's gonna be xn minus 1. So n can be any number, you just pick it up, x1 and x0. Then it's a combination of the first of this. So this one is divided differences between the first group, xn, x minus 1 until x1. So minus with the second group, which is this one here. So it's going to be f xn minus 1, xn minus 2, and it will go to x0. Divide with, okay, divide with xn minus x0. Okay, so this is how you want to find the divided differences. Now, let's move straight to the example here. Let's say that you want to find, let's say that we want to find the first divided differences. So for this one, I already put it here. I already write here. So I'm going to use this one. Okay, let's say you want to find what is a linear interpolation. You want to estimate. Okay, let's say that you want to estimate ln 3 using linear interpolations between ln 1 equal to 0 and ln 6 equal to 1.791759. So in here, because you have decided to use linear interpolation, therefore this one here, your n is equal to 1. Okay, then you have 2 points here, which is point x equal to 1 and x equal to 6. All right, you have x0 as x0 is 1 and your x1 is 6, and the value of fx0 is equal to 0, and the value for fx1 is 1.791759. Okay, so what you have to do next is purely very simple, which you have to plug in into the formula. So again, I'm gonna highlight to you the formula here for the linear interpolation. So it's supposed to be f1x, fx0 plus x minus x0 and fx1 x0. Okay, so here again, this is your first divided differences. Okay, so this is your first divided differences. Okay, I put it here, first divided differences. Okay, so how you want to find these first divided differences is simply by using this formula here. Okay, so you need to plug in the value of fx1, which is 1.791759 minus 0, divide with the points here, which is the difference between the point here, which is 6 minus 1. Okay, therefore, your first divided differences, the value is like this one. Okay, so you are done with the first divided differences. Therefore, you can plug in into the formula here. So if you still remember, the formula is as highlighted in the blue color here. So this is the formula, and you plug in, you will get this one. Okay, so you can see here that, you can see here that your x naught is 0. Okay, so this is x minus x naught. Okay, so this one, okay, I'll just show you where it comes from. Fx naught that you need to find, this is the one. Okay, x minus x naught, so this is x, the value x that we want to find, minus 1, because our x naught is 1. And then multiply by the first divided differences here. So the first divided differences is this one. Okay, so 0.358351. And when you solve this, you will obtain this equation. So this is f1x in terms of the equations. Now, the questions ask you to estimate ln 3. So ln 3 means your x is equal to 3. So that's why you need to plug in into your approximation formula here. So that's why you have your x equal to 3 here, and everything else is equal. Then when you solve this, you'll get the approximation as 0.716702. Alright, so that is linear interpolation. Alright, I hope that you can try to estimate ln 3 using smaller interval. So in here, you just have to take note that x0 is 1, and then your fx naught given in here is equal to 0. Now the second pair is x1 equal to 4, and then your fx1 is equal to, so this is the value, 1.386294. And I hope you can do this for linear interpolation using Newton divided differences. Yeah.